Hey guys, this is Professor Janacek. I want to talk about how to find the volume of a solid. Now let's remember how to find area. The area is the integral of the curve times the width as the width goes to 0. You might not remember it exactly in that form, but if you recall that our curve can be defined by a function and that our width, which is delta x, can be approximated by dx, then you'll see, yes, area under a curve is just the integral of f of x dx. Along those same lines, to find the volume, we'll simply integrate the area times the thickness as our thickness approaches 0. So let me make sure this makes sense. In a rectangular sense, the area would be length times width. So we have the length, which is defined by our curve, and then we just multiply by that by the width to get the area. For volume in a rectangular sense, we would find the volume as length times width times height. But that length times width, that is our area. And then we multiply it by the height, which I'm calling here the thickness of it. Okay, that's starting to make sense, I hope. So we're going to find the area of the base and then multiply it by our thickness, and that's going to give us volume. So that's the basic idea of how to find volume, regardless of the method. Now, there are a couple of methods. I want to talk about the ring or washer method, also sometimes referred to as the disc or slice method, if the inner radius is equal to 0. So let's start with a three-dimensional shape, something like that, and let's take a little slice out of it. Now the idea is that we're going to take many little slices and we're going to add them all up. Again, that takes us back to the whole Riemann sum idea. But for now, let's just look at that one little slice. You can see that little slice looks kind of like a ring or perhaps a washer. Now I'm going to kind of focus on this little bit. It would be almost as if I took that little piece of this little rectangle and rotate it around, in this case the x-axis, and that's going to give me my washer or my ring. And that's what we're going to look at. Now, looking at this shape, how do I find the area of that? Well, it's a circle, so the area of that would be pi r squared, and then our volume, of course, will be area times thickness. So if our area is pi r squared, then our volume will be pi times the radius squared times the thickness now. Okay, but in this case, what is our radius? Well, the radius in this case, we actually have two of them. Because we have an outer circle and a little inner circle, then we have an outer radius and an inner radius. In order to use this formula, we will simply take the outer radius squared and subtract off the inner radius squared. And that's how we will develop this formula. Now, these radii will be defined by functions, so that gives us the formula v is equal to the integral of pi times f of x squared minus g of x squared dx, where f and g define our outer circle and inner circle. I don't suggest that you memorize this formula. Instead, just remember how it was built. Remember, this part here is the area, and in this case, the area is pi r squared. So that r squared gives me the f of x minus g of x. And then this last little bit is my thickness. Right, so that's the way to remember this, not by memorizing this big volume formula, but by remembering how it was built. We could also take a look at this if we are rotating about the y-axis, and then we will have our functions in terms of y, and we'll integrate with respect to y. Now, all of this might be a little confusing, so let's kind of summarize how to kind of figure out what's going on here. I like to kind of go through a little bit of a checklist. If we are revolving about the x-axis, all right, so that's this part, and our piece that we're looking at is perpendicular to that. If that's the case, then we will integrate with respect if I could spell, with respect to the x-axis, or with respect to x, I mean, and we'll use the area is pi r squared. Now, if we happen to be revolving about the y-axis, and so revolving about the y-axis, and our piece that we've selected is perpendicular to the y-axis. Then we will integrate with respect to y, and we will use the formula the area is equal to pi r squared. So I kind of use this as a checklist. If I have this, then I do that, and I end up with that formula. Again, I don't memorize the formula. I actually remember the area formula, which I already have memorized, right? So do that, and that builds my equation. Now, if I'm looking at a piece that's not perpendicular to my axis of revolution, instead it's parallel, then we actually use the other method, which is called the shell or cylinder method, and I've got that in another video. So enjoy!